In 1872, American physician George Huntington published a paper called On Chorea, which was an accurate description of a disorder we know today to be called Huntington's disease. However, symptoms of Huntington's disease have been written about since back in the 16th century. Renaissance physician and alchemist Paracelsus coined the term Chorea to describe the uncoordinated movements of people with HD. Then, in 1692, English colonists in Salem, Massachusetts thought that the people with HD were possessed by the devil because of their uncontrollable body movements, and then they were all burned. That was a fairly quick history of HD, but now for the basic overview of what it really is. HD is an autosomal dominant gene. What this means is that the disease doesn't lie on the X or the Y chromosome, but rather on one of the other chromosomes. In most cases, there is one parent with HD while heterozygous, and the other is homozygous recessive. Then their children are at a 50-50 risk of getting it. In the rare scenario that one parent has two defective genes, all the offspring will have HD. That was the basic overview. Now for the in-depth genetical analysis. Remember when I said that it is an autosomal disorder and has nothing to do with the X or the Y genes? It was kind of a lie. Technically, obtaining the disease has nothing to do with the X or the Y genes, but the severity of the disease does. Before explaining that, however, we must first realize why Huntington's occurs on both a chemical level and a chromosomal level. First, in 1983, the genetic marker for HD was found in chromosome number 4. Chromosome 4 is also responsible for piebaldism, Rieger syndrome, renal amyloidosis, and Fletcher factor deficiency. However, the portion responsible for HD is located on the short arm of chromosome number 4, placed approximately here. Now, the HD gene produces a protein called Huntington, and this protein is mainly expressed in neurons in the brain and plays an important role in the function of the basal ganglia. Pieces of the puzzle should be coming together now. We know that HD people have motor issues, they also have emotional issues, and they also have learning issues, the same exact areas the basal ganglia deals with. Damage to the basal ganglia also causes related conditions like ADHD, OCD, Parkinson's, cerebral palsy, Tourette's, stuttering, and many other related conditions. Now that we know that a mutated HD gene causes a deterioration of the basal ganglia, let's go deeper, down to the DNA. The HD gene contains a trinucleotide repeat. This means that it is a sequence of cytosine, adenine, and guanine. Normal people have 8 to 35 repeats of the CAG sequence, while HD people have more than 35 repeats with larger copies. The more repeats, the younger the disease starts, and the more severe it ends up being. Now, remember when I said I half-lied? This is where it comes into play. Larger repeat lengths tend to cause an earlier onset of HD. But when someone has HD, expanded repeats are really fragile and they have a tendency to enlarge, especially during the production of sperm. So males have a tendency to pass along a more messed up version of HTT than females. We previously touched on symptoms of HD, but let's go a little bit more into depth. First off, family members might notice that someone who has HD becomes uncharacteristically irritable, depressed, or angry. HD may also affect judgment, memory, and other cognitive functions. Concentration also becomes increasingly difficult. During the middle stages, more noticeable symptoms emerge, such as uncontrolled movement of the fingers, feet, and face. Slurred speech and other speech impairments start to occur. At the final stages, severe chorea is common. Swallowing and speaking are almost impossible, and weight loss starts to occur. Weight loss is one of the most severe symptoms because death is not caused by HD directly. It's because HD symptoms open portals for other infections to come, and weight loss weakens a person's ability to fight those infections. When someone starts getting HD depends on how many cytosines, adenine, and guanine repeats one has. More than 60 means you'll get it at 20 years of age or younger, and 40 to 50 means you will get it in your 40s to your 70s. Lifespan is approximately 15 to 20 years after the characteristic manifestations of the disorder. As I stated before, death is not caused by HD directly, rather associated complications such as pneumonia, heart failure, choking, and suicide. The lifestyle of those with HD is very grim and dull. At the later stages, people with HD can't walk, talk, or even eat. Eating and drinking, when you can of course, are also chores. Huntington's patients burn through approximately 5,000 calories a day and use up a lot of water, so all that must be made up. Hope is still there, however. There are a countless number of ideas and theories that are being tested right now to find the cure for HD. Currently, as of now, there are no cures, only treatments to try and alleviate the symptoms, such as antidepressants, antipsychotics, tetrabenazine for the cholera, and rehabilitation. The theoretical treatments are far more creative, however. Currently, the most promising is gene silencing. is basically using a small special interfering RNA molecule to knock down mutant HTT. However, even though this is successful in mice, the mice had a human mHTT, and the treatment has left the regular mouse HTT alone. It would be difficult for the siRNA to leave our regular HTT gene alone, and we also know that if it was ever deleted, it would be lethal to us. Stem cells are also very promising. By transplanting them to damaged areas, they should be able to hypothetically make replacement neurons and also alleviate the symptoms. It will not, however, stop the continuing damage caused by Huntington's, and it's still very speculative, but it still has lots of potential. Researchers have also found out that having an active lifestyle delays the symptoms. Don't be scared though, even if you have HD, you're not alone. 3 to 7 out of 100,000 people of Western European descent have it, and 1 in a million Asians and Africans have it. With billions of people in the world, that's a lot of people with HD. There are also many organizations made for support, with the major one being the Huntington's Disease Society of America.